Welcome guys, my name is Boris and I am a computer engineering student in my 5th bachelor semester at the Technical University of Berlin. And on this channel I want to talk about educational stuff and just topics that I've learned and may bring you value, and perhaps a few lifestyle topics such as cooking perhaps. But in this video particularly, I want to talk about what you actually would learn when you apply to computer engineering at the Technical University of Berlin. Disclaimer, all those information that I will give you or provide you are my personal experiences and what I have learned. They might change very so slightly because I'm in the fifth semester, so before 2 years I have had those topics and they may have changed a bit, but yeah, let's jump right into it with the general idea of what computer engineering actually is. Okay, so computer engineering is basically a combination of computer science and electrical engineering. So here at the TU Berlin you will have 3 or rather 4 areas of study. Obviously electrical engineering, computer science and maths, but you'll also have an area which is more like computer organization, architecture, operating system, or like computer networks in general. So for the plan, I myself will base the structure of your semester on the recommended study plan, which is in the link in the description below. And I would also recommend this plan, except for one change, which is in the 2nd semester, so that will be in the future video. So let's get right into it and get started with the topic everyone likes the most, maths. Okay, so in the 1st semester you will have Calculus 1 and Algebra 1. So when you look into the plan, you might get a bit confused because it appears as one course, one module, but they actually are 2, because they have 2 lectures, 2 different sets of tutorials, 2 exams, but you will need both of the exams, you'll need to pass both of the exams to pass the whole module. Okay, with that out of the way, what do you actually learn? So in Calculus 1, you'll start learning the basics of sets and how you work with them, a cool method of proof called induction. You will learn about sets and sequences, how to work with functions and how you can do various proofs with them. A really amazing thing called Taylor polynomials, with which you can approximate the value of a function, especially non-polynomial functions, with a polynomial. And an even more amazing thing called Taylor series, with which you can basically split up every function into a sum of multiple sine functions. Those 2, in particular the Taylor series, will be pretty important in later electrical engineering courses. Similar to that, there's the Fourier analysis and Fourier series. You will work with limits and the rule of L'Hopital, and you will basically just relearn a bit of the school maths like differential equations and integrals. As I mentioned, those are the topics that I have learned in the winter semester of 2018 and 19, so the topics might really change, but only like really a tiny bit. So let's continue with linear algebra. You will learn a bit about complex numbers and about matrices and how to solve linear equations with them. This will be a fairly big part. Additionally, there will be a few definitions, for example, for properties of matrices or functions, and this might sound pretty hard and hard to understand, but they really will be one of the easiest things, trust me. Then there will be a few new mathematical operations, since you will be working with matrices and vectors. Just to mention it, vectors are basically matrices just with one column. And you will also learn about eigenvectors and eigenvalues. So all in all, there's quite a bit about matrices, so that will be the main topic. So again, this all might seem like a lot, and it is quite a lot, but almost everything, especially in linear algebra, is basically a cookbook. So you will have a cheat sheet that you can write at the TU Berlin in most courses. How long it will be depends on the professor. For example, when I had my exam in linear algebra, for example, I could write 2 pages? I don't really know, but 1 or 2 pages with whatever I want. So I could write all the formulas, all the definitions and everything, all the algorithms I would write on this sheet of paper, and I could take that with me to the exam. So in the exam, it will just be looking at your formulas and using them. So you should still exercise and prepare for the exam, obviously, but you don't have to learn all the formulas, definitions, and algorithms by heart. You just really need to know how to apply them. And I personally always prepare just by going through all the tutorials, because they will be fairly similar to the problems that you have to solve in the exams, and you have solutions, so you won't be like, oh, have I done it right or not? Next, I would like to continue with the electrical engineering course of this semester, which is Principles of Electrical Engineering. At least that's how I would translate it, because in German it's Grundlagen der Elektrotechnik, for the Germans out here there. And I would like to continue with this because, I'm sorry, this will be also a lot of maths. Now this course somewhat has a little problem because the maths that it uses is not taught yet. You will learn this maths about three-dimensional space and higher functions in the next semester in Calculus 2. So it's basically a hen or the egg problem. What came first? In the end, you'll have to learn it no matter what. So, okay, with that said, you will obviously learn this maths, because you will have to integrate and calculate a few formulas in the three-dimensional space, because, well, the world is in three-dimensional space and the physics work on three-dimensional space. Let's exclude now this time dimension thing. You will learn about the charge of objects and how to calculate them. You will learn about electrical fields and how protons and electrons behave in those and how they will interfere with each other. You will learn about potentials and what they mean, how the materials and its shapes affect the current and the electrical field. You'll obviously learn about magnetic fields and how they are created through the moving particles like electrons, and what effect those magnetic fields will have. If you have magnetic fields, you'll obviously also have induction. So that's another topic. And then you'll just in general learn how magnets actually are made and how they work. All of this is quite a lot of maths, but similar to calculus and algebra, it really just is cookbook. You will have your cheat sheet and you will just have to know how to work with the formulas. The perhaps a bit tricky part is that you will have to know how the forces and the vectors work in three-dimensional space, just to not get confused. So my real tip is really embrace the tutorials, because they will just show you how to use the formulas. The same thing applies to algebra and calculus. In the lectures, you will really learn a lot about the proofs behind the formulas that you can use and why they really work. All of this really isn't that important to you. You really just need to know the formulas in the end, which will just be 1 or 2 formulas per lecture, and how to use them. And this how to use them is taught to you in the tutorials. But the professor here in this course, if it's still him, Professor Völker, is a really nice guy, so don't be scared of him. And one last thing I really want to mention here at this point is ask questions. Like, really, they don't only help you, they help literally everyone. Because in the end, you will not be the guy doesn't understand anything. You'll be rather the guy, he understood so much that he could ask a question. So it's a win-win. You get to understand the question that you had, or get the answer, and everyone will think that you are smart. Okay, so we're getting there. Let's continue with a rather relaxing course, Introduction into Programming. So a little short story about me. In school, I had zero computer science. I didn't know how to program or even how to start a environment for programming. I literally only had an internship at Biotronic, and there I learned about simple data structures and what for loops are, just the things that I could basically learn in a few hours, or maybe perhaps even a few minutes on YouTube. But it was a really great experience and it was really fun and I learned a lot. So this course will give you a crash course at the beginning and you'll start learning with C. I know not quite a lot of people like C because it's so difficult, but it's not that difficult. It's just you have to think a bit more and other languages like Java or Python will just do more for you. But in the end, it's a really nice programming language. Okay, so back to business. I mentioned the crash course that they will give you. This will be like, I don't know how long it was, like 2 or 3 weeks. I don't know. We'll just learn how to program C, and you will have little homework assignments where you have to program little things. So you will have a bit practical experience. And you will learn what the big O notation means and how it works. But the really heavy focus of this course is on sorting algorithms. You will basically just learn, like, I don't know, 8 sorting algorithms and how to implement those and why they are good in this particular situation and bad in this one. And yeah, that's basically it. So in future semesters, especially in the third one or upwards, you will see like a little pattern where you will have one fairly easy course, mainly 3 who are like, okay, they are a bit demanding, and one that will basically consume all your time. In the first 1 or 2 semesters, it will be more mellow, and it will be still quite a lot, especially if you just came out of school and want to apply for university. It will be quite a change because you really have to do quite a lot. But it's all fun because it's really interesting and you really learn a lot. Coming to the last course, we will talk about computer organization, or rather computer architecture. This module will introduce you to the world of processors and really low-level processing that they have to do and how they are built and how they operate. You will start by learning how to convert between binary, hexadecimal, and how to do basic calculations with those. You will get to know about Boolean logic and how they are implemented in gates and how they will be used in the processors themselves for the individual components. And you'll have to know how to solve Boolean equations with like 2 or 3 algorithms that you have to use. So, and with those logical building blocks, you will get to build step by step, well, not physically build, but you'll get to build a basic 1-core processor, such as this one. I know it looks quite complicated, and it's pretty cool for the nerdy guys, at least, but you will really start building it one piece by the other. And for example, by building up the arithmetical logical unit, short ALU, and then put all the pieces together and we'll understand how this processor will work. And I have mentioned that you will be working with assembler. So that's another programming language that you will learn about if you don't already know what it is. And you will only need it for 1 course later on in your semester, which is in the 5th semester. Continuing, you will evaluate the power of a processor by having a few metrics at least. And now to the most important part, you will get to know how a processor actually works through one line of code by going through about 5 phases, such as instruction fetch, instruction decode, execute, memory, and write back. And again, this process scheme or those steps depend on the processor itself, but this is the basic idea, and at least this is what you should learn, or at least I learned, and how those phases can work in parallel using pipelining and the hazards that can appear with this process. And in the end, you will somewhat get an understanding of caches and how the layouts are and how they work and the mapping of it. So, this is the end of the video. I really wish you a lot of fun while learning and stay excited about the things that you learn, because it is pretty fascinating, at least to me, you know. And if you have enjoyed this video, I will soon make a follow-up video about the next semester, and I will try at least to put it into the link into the description below, and perhaps I can somehow manage to let this video pop up somewhere in the screen. And with that said, thank you for watching and have a nice day.